Hey everyone, in this video we're going to go through the statistics section of your exam revision theory. So I'll do a separate video for each topic just to make it a little bit easier and also to keep the videos a little bit shorter. All right, so with statistics we covered the mean, median and mode. So first of all, let me just get my highlighter ready. The mean and median are measures of centre. Okay, so if you were to, want to know what the average is, okay, we refer to that as measures of centre. So we use mean if the data is kind of symmetrical. So if I wanted to do, calculate the average height of students at Kilbreda, they're probably going to be symmetrical. Okay, so you have the really short people down one end and the really tall people down the other, but most people are roughly around the same age. So it's kind of, the data is what we call symmetrical. And we use the median when we have skewed data. So skewed data would be if we had, it wasn't symmetrical. So house prices are always a good example. And the suburb of Mentone is fantastic because we've got some really, really nice houses along Beach Road that are worth millions of dollars, like some, maybe around $3, $4, $5 million. Whereas your average house in Mentone is probably around $1.5 million. So the data is kind of skewed because you've got these really, really, really expensive houses, and you might even have, units that are a little bit cheaper. Okay, so the median is what we use when we've got data that is skewed. Also think about the age of people in, let's say, in the school. Okay, so we've got a whole bunch of students, maybe around 900 students, and you're roughly around 12 to 18 years old. And then we look at the teachers, let's say there's 100 teachers, and we're probably anywhere between maybe 25 to maybe even 80 years old. So if we were to put everyone together, obviously all you students would skew the data a little bit because there's so many more of you and you're quite a lot younger than us teachers. So we would probably take the median. Okay, so the mean when it's symmetrical, the median when it's not symmetrical, and that's probably what it says down the bottom. All right, so the mean, what we do is we add all the values together, so sum of all the data values, and then we divide by how many data values we had. So if we were looking at the average height of students in our class, we would add up the height of all 22 students and then we would divide by 22. Okay, the median is your middle value. So what we have to do to take the median is to put the numbers in order. Okay, you can't take the median unless the numbers are in order. So place them in order. And we take the middle number. So if there's an odd number of values, there's clearly one median. But if there's an even set of values, then the median is halfway between the two middle. So what you do is you find the middle between the two of them. And sometimes you can tell what it is, but if it's too hard, just add them together and divide it by 2. So whatever the two middle numbers are, so in this example it's 20 and 21, so we add them together, divide by 2, so that's 41, and that's where the 20.5 comes from. All right, your mode is the most common value or the most popular. So if we are referring to categorical data, so categorical data is usually where we can give a worded answer. So what's your eye color, what's your hair color, what's your favorite pizza topping, stuff like that. So, let's say we did a favorite pizza topping and most people like Hawaiian. All right, so that would be our most common. You can have numbers that are for the mode. Okay, so you might do shoe size or age. Okay, you can still have the mode for numbers as well. You can have a set that is bimodal. So if you think of a bicycle, 2 wheels, so BI just means 2, so 2 modes. Now, usually we say if there's no clear mode or there's no clear 2 modes, but it's not bimodal, then we just say there's no mode. Okay, we can't say take the favorite pizza topping of people in our class, and 5 people got Hawaiian, 5 people chose meat lovers, 5 people chose vegetarian, 5 people chose chicken supreme. Don't know what pizza toppings there are, but you can't have multiple modes. All right, and an outlier, which we'll probably look a bit more into next year, is one that doesn't fit the data. So if we were to take the age of people in our classroom, including myself, I'm a bit older than you guys, I would be an outlier, okay, because I don't fit the data set. All right, so let's fill in this building understanding. So the mode is the most common value. The median is the middle value. Just remember they have to be put in order. And to calculate the mean, you add up all the values and divide by how many the number of values. All right, so state the mean, median, and mode for these. All right, so I'm going to do the mean, the median, and the mode. Actually, what I might do is just move the median over here, because I'm going to have to do some calculations for the mean. So do median here and then mode. All right, so for your mean, you add up all the numbers. So 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 4 is 11, plus another 4 is 15, plus 6 is 21, 3, 5, 7. Cool, just making sure I got that correct. And then how many we have. So we've got 1, 2, 3, 4, 5, 6, 7. All right, so 21 divided by 7 is 3. Okay, and we can see that kind of makes sense. So if you made an error anywhere and you got an answer that wasn't even between 1 and 6, you're wrong. Okay, so it's probably a good idea to think about what the mean might be before calculating it. All right, the median is our middle value. So we've got an odd set of values. So our middle value is 2. Okay, so there's our median. And our mode, the number 2 occurs 3 times. So it is also 2. All right, let's move on to question B. So we've got our mean, and then we'll do our median and our mode over here. All right, so let's add them all together. So 7 plus 11 is 18, plus 14 is 32, plus 18 is 50, and that's 90. Let me just double check. So 18, 22, 32, 40, 50. Okay. And then we've got 1, 2, 3, 4, 5, 6. 6 values. All right. So if you did that on the calculator, you would get 15. Your median. So we've got 6 values. So your median is halfway between 14 and 18. So you might think, oh, it's going to be 16. But remember, you can also add the 2 numbers together and divide by 2 will also give you the halfway. So 14 plus 18 is 32, divided by 2 is 16. So you can get 16 that way as well. And your mode is 20. Okay, so we've got the mean, median, and mode. All right, moving on to the next set of key ideas. 2 measures that help to describe the data is spread. How the data is spread are the range and interquartile range. Okay, so your range is pretty easy. All right, we just take the highest value and subtract the smallest value. So that just tells us how spread the data is. So if we go back and to do the age of students at the school, so let's say the youngest was 12 and the oldest was 18. So 18 minus 12 is 6. So there's 6 years difference. So not much difference. Whereas if we did the teachers, let's assume the youngest was 25 and the oldest was 80. So that's a difference of 55 years. So obviously a lot larger spread in ages for the teachers. Okay, with the interquartile range, now I haven't got the theory here, but basically your interquartile range, and if you like, you can look through your previous notes, is just your upper quartile minus your lower quartile. So your upper quartile is just the middle of the upper half, and the lower quartile is the middle of the lower half, but that won't be on your exam. Okay, stem and leaf plots. So make sure you can do stem and leaf plots to present data. Whenever you do a stem and leaf plot, you do need to have a key. So we can see a key here. It just tells the person how to interpret it. So it could be 24, it could be 2.4. We don't know. That's why we need the key. So with your stem and leaf plot, we tend to group them in data. So these numbers here are 12 and 16. So we've just separated the 10s, the 1s. Okay, so 12, 16. Then we've got 22, 23, 24, 27, 31, 32, 34, 37, 38, 39, 42, 43, 44, 45, 48, 57 and 59. So you read the stem and then the number on its own. Okay, so that's the stem and leaf plot. It also tells us how spread the data is, or the distribution of the data. So what I like to do is just go around it like that. And if it's symmetrical, which it is in this case, okay, we call that distribution symmetrical. It means your median is in the middle, okay, and we have pretty much the same number of values either side, okay, so it makes it symmetrical. These ones here are skewed, so we'll have a look at this one. This is a back-to-back stem and leaf plot, so back-to-back stem and leaf plots allow you to compare two groups. So you can see here we've got two teams, I think. No, not two teams. We've got scores for the last 30 football games. So I guess the score when they win and the score when they lose. I just read that as soccer, and I'm like, how would you kick 109 goals in soccer? But let's say it's AFL footy. It might make a bit more sense. So let's read the key. So 10/9 means 109. Okay, so just going back with the distribution, you can see it does say it's symmetrical here. So if I just went around like that, you can see it's kind of like a hill, like a nice symmetrical hill. Whereas on the losing scores, it's skewed. Okay, so see how your bump is off to one side. So that means your median is also off to one side. All right, what other data can we tell you about that? So it does say the lowest score, the highest score, stuff like that, okay? You can also get your mean and your median and also your mode from a stem and leaf plot. So you don't have to go and write the values all out again. So if you were doing the mean, no, not the mean, sorry, the median, count up how many values you have. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So what we need to do is count up to 9. So that would be half. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So your halfway point is going to be between 3 and 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, not 3 and 6, sorry. That is 83 and 86. So we can add them together and divide by 2. Or you can just say, well, what is halfway between 83 and 86? Let me just quickly do that. So what is that? 84 and a half. Okay, so that would be your median for losing scores. And you can do the same for winning scores. So just counting up how many values you've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So your median, so half of 12 is 6. So 1, 2, 3, 4, 5, 6. So your median is going to be halfway between these two because we've got, what have we got? Even number of values. So that number there is 104. And then we've got 108, and then you can divide that by 2, gives you 106 for the median. I might just write that in case you're wondering what that is if you're just looking at the document. All right, so let's quickly do some of these questions. So the stem and leaf plot shows the length of time in minutes Alexa spoke on her phone for a number of calls. How many calls are represented in the stem and leaf plot? Okay, so let's count them. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to put that 9. Okay, what is the length of the shortest call? All right, so that's why it's important to read your key. So 2/1 means 21. So 0/8 means 8. So the shortest call was 8 minutes. The longest phone call is 35 minutes. What is the mode? So the most common call time, so I can see that is 21, occurs twice. What is the median? So we need to find the middle value. So because we've got 9, we're going to count to 4. So 1, 2, 3, 4. And the fifth value is going to be our median. If you want to check, just count the numbers either side. So I should have the same numbers either side of the 1. So we've got 21, 19, 15, and 8. And then 35, 34, 27, and 23. So 4 numbers either side of 21. So the median is 21. All right, question 2. This back-to-back stem and leaf plot shows the thickness of tyre tread on a selection of cars from the city and the country. How many tyres were tested altogether? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Where are we? I feel like I may have miscounted. So 2, 4, 6, 8, 10, 12, 16, 18, 20, 2, 4, 6. Oh, I just got 28. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, no. There we go. I miscounted the second time. Find the median tyre tread thickness for tyres in the city. So the median, another way you can do it is just cross off 1 from each end. Just make sure you choose the right end, that's all. Until you get to the middle. All right, so we're going to be halfway between, no, how did I do? Oh my God, I did that. No, I didn't, sorry. Just getting a little bit distracted because it's on the left side. Oh my gosh. So that is halfway between 10 and 11 is 10.5. It's a little bit harder to see because we're used to reading from left to right, and here we're going from right to left. So it's 10, 11, 11, 13, 16, 18, then 21. So I'm just going to double check that. So I've got 1, 2, 3, 4, 5, 6. Oh no, that's 1, 2, 3. No, I did it between the wrong two numbers. Luckily I checked that. Let's just cross out that. Okay, so it's halfway between 10 and 8. Why would they give us a tricky one? So if you wanted to count the numbers either side, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Cool. So halfway between 10 and 8 is 9. It's a bit hard to see on that side. If it is too hard, just write the numbers out, although that's very time consuming. All right, the country. So how many have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to count to 6. 1, 2, 3, 4, 5, 6. So it's halfway between these two. 2, 3, 5. 2, 3, 4, 5. So we've got 15. Is the distribution of tread thickness for city cars more symmetrical or skewed? So we're looking at city cars. Oh, that's definitely skewed. So see how the peak is at the end. So it's going to be skewed. I might just highlight that. Save me writing it. Is the distribution of tread thickness of the country? It's pretty symmetrical. Probably not enough data, so it's going to be symmetrical. All right, let's move on. All right, so a frequency table shows the number of values within a set of categories or class intervals. So grouped numerical data can be illustrated using a histogram. The height or column corresponds to the frequency. Oh, I can't believe I'm just reading that. You can read. All right, so like a stem and leaf plot, a histogram can show if the data is skewed or symmetrical. So you can do the same thing. You can draw a thing going up like that. So it's kind of like a hill. So that is symmetrical. And this one is also symmetrical. So you want that peak in the middle. Sorry, not symmetrical, skewed. if it's meant to be symmetrical, the peak would be in the middle. Okay, so it's definitely skewed. Sorry, that's me getting a little bit tired. All right, so with your histogram, what we have down the bottom are our class intervals. So this first one here is between 60 and 65. So you can see it's 3. If you wanted to convert it into a percentage, it's just 3 over 25 gives you the 12. Okay, so you can see the same, we've got a percentage one over here and the frequency one over here. So it's showing the same data. One's just as a percentage and the other one as just frequency. So it hasn't been converted. If we're looking at the modal interval, so what I am saying there is modal. All right, so that's the same as the mode. All right, so the modal interval is the peak. All right, so it's between 75 and 80, and you can see it's the same here. And you can also see on your frequency table is there. All right, so let's go through the building understanding questions. So state the missing numbers in this frequency table. All right, so your frequency, they all have to add up to 10. Okay, so we've got a total of 10. So 1 plus 3 is 4, plus 4 is 8. So that means B must be 2. And then to calculate the percentage frequency, we just go whatever the frequency is over 10. So I'm just going to do that over here. 1 over 10 times 100. That's where the 10% comes from. So for 5 to 9, our frequency is 3 over 10. Multiply that by 100 and we get 30%. 4 over 10 times 100, that gives us 40%. And then lastly, 2 over 10 times 100 equals 20%. Right, so all your percentages should add up to 100. So that means F is equal to 100%. Okay, question 2. This frequency histogram shows the number of books in which the number of pages is within a given interval for some textbooks selected from a school library. How many textbooks had between 100 and 200 pages? All right, I'm just going to change my highlighter color. So 100 to 200, so we're looking at this one here. So how many? There's 2. All right, so we'll just read across. How many textbooks were selected from the library? So we need to add them all up. So this one's 2, this one corresponds to 6, this one corresponds to 7, this one's 5. So we just add them up. So 2 plus 6 is 8, plus 7 is 15, plus 5 is 20. What percentage of textbooks had between 200 and 300 pages? So there were 6 books, but if we're doing it as a percentage, 6 over 20 times 100, which is going to be 30%. And then 200 to 400 pages. So now we're looking at 2 intervals. So we're going to have to do 6 plus 7 over 20 times 100. So 6 plus 7 is 13. All right, so that's 65%. All right, and that's it for statistics. Bye-bye.